DC to DC converter, aka what?
Switching regulator.
All right, Brown, you got one. Good job. Because this is a regulator, isn't it? It is. We waited till the very last lesson, BO5, to dump it on you. What really is that? We don't do it BO4 because we're dealing with all this stuff is on a chip. Op amp, logic gate, flip-flop, oscillator. That's BO5 information. So it's a regulator still. Still trying to maintain nearly constant output. So some key things about this. We talked about duty cycle, the different functional areas. This portion right here, these two resistors in series, what is that referred to?
Voltage divider.
Okay. This is called the output voltage feedback. You can call it that whatever you want. Output voltage feedback. Hey, that's one of the inputs to what? The comparator. That's right. Output voltage feedback is the input to my what?
Inverting.
My inverting input of the op-amp amplifier, which is known overall as our comparator. Because what are we doing? We're comparing this level of change to a reference. Those are the two inputs. You need to know them. Not know them. See what happens. The output, whether it be a high or low, because we're at that stage, we're at logic level stage. Input to the AND gate. I have my oscillator circuit here. It's going to keep the time. And the output's going to oscillate at the rate. We have this, what do we call this stage? Yeah, it's a switch driver. Driver switch driver. Because it's about this guy right now. This is our power switch. So we're using the word switch, so these transistors must be switching between saturation and cutoff. The output of this thing is basically a rectangle wave in conjunction with the input that's already filtered. What do we call this thing as far as like how the power switch is operating? Yeah, it's a duty cycle. Because the level of output and the duty cycle of this guy here are inverse to each other. If we're trying to maintain or adjust the level of output due to changes in the load. It could be line 2. We're mainly just worried about the load right now. And forever. This output right here, it's kind of like, it's not exactly straight DC. It's pretty close. We call this the ripple. It's just a recap from last annex, really. The ripple. So now, a couple of things over here. Switching regulator, DC-DC converter. If the level of output decreases. So in other words, this output voltage right here, what do I want to do? I want to bring it back up. So the duty cycle, to keep it short and sweet, has to do what? Or the transistor has to switch faster, its duty cycle work harder. So if the level of output is low or decreases, the duty cycle has to increase to bring it back up. And that has to do with the charge and discharge of the inductor and the charge and discharge capacitor. But if we're trying to bring the level up, what's going on here? Duty cycle a little bit faster. Yeah, we want this guy to, well, we're below the level. Level's low. What do we want to do? Yeah, so what's got to go on here? Yeah. Yeah. So, well, actually charge. So the capacitor discharge. Because now there's time to do so. So it really boils down to this. Whatever this capacitor, either level rises or lower, it's going to reflect what the output voltage is going to be. So we're just trying to sustain the level of output due to change in load. If my output is above the level, what's a duty cycle transistor have to do?
Decrease.
Yeah, it's got to chill out a little bit. So ultimately, the level of output and the duty cycle are inverse to each other. We already identified our two inputs to our comparator, didn't we?
Yes.
Output voltage feedback, OVF. Output voltage feedback, and the VREF, or the reference voltage, are the two inputs. Yes?
Meanwhile, reference voltage and voltage out are in series. I mean, not in series, but the same. Proportional.
Yeah, because we can do this now. Yeah, because I kind of skipped it. Meanwhile, yeah, I like that. I'm watching a Scooby-Doo episode or something. Meanwhile, at the bank, it's getting robbed. Shit. Whatever. VREF. VREF to the V out, their relationship is what? Direct. It's just like those other regulator circuits. When we messed with the output, the reference voltage, it always affected the output directly, didn't it? So if this, example, V out this. If we're ramping up, oscillator signal and the transistor's ramping up, what's it doing? And ramp down is cut off. Questions? Characteristics.